Alright guys, here's your video on how to solve for sides in similar triangles. So we are going to use a lot of the properties we learned previously, how to write the ratio of corresponding sides, how to pair up equal angles, even proving similarity to go through some of these and solve for missing sides. So as noted before, two triangles are similar if they have the same shape but different sizes. They could possibly be flipped, turned, rotated, reflected, whatever words you want to use to describe it, but they may not be in the same orientation. So similar triangles, as we know, have all equal angles and the corresponding sides have the same ratio. So they've either been increased or decreased by the same factor. So you'll notice in this diagram here, the angles we use capital letters for. So we've got A, B, C, and D, E, F all in capital around the outside. And sides we use lowercase letters for. And not only do we use lowercase letters, but they're always opposite of that angle. So if you slide through the center of your triangle here, you notice the angle F is that capital letter, and the opposite side we call side F. And we use a lowercase letter to write that. Another way you might see angles written, so for example, angle A could also be written as angle BAC. And what that means is if you start at B, you trace along the side of your angle down to A, and then you trace along to C. So you're following that BAC path. This is the angle that we're talking about, and you can see how that middle letter is the one that's being indicated for that angle. So just a bit of key pieces to help us through some of these questions here. All right, first example, let's get going. So first, with these two triangles, I want you to start by proving that they're similar and stating the similarity statement, and then we're going to move on to solve for the missing sides. So right off the bat, I noticed those angles, they're being marked, so I'm going to start with the angles. Angle P matches up with angle N, angle B, and it doesn't matter which one you do first, second, and whatnot, matches up with angle T. And in my first triangle, angle K matches up with angle D, and I can see that by the symbolism used in the angles. Notice the first three that I wrote all came out of that first triangle, and the last three all came out of the second triangle. Okay? So I've proven it similar by having at least two sides with the same angles. You only have to actually write two to prove that. So the similarity statement, therefore, triangle PBK is similar to triangle NTD. All right, so I've gone and just color coded here my sides. So going from the one tick mark here, P, to the double tick mark, I did in purple. So you can see I'm going from N, the single tick mark, to the double tick mark, I went in T. Or you can even see that first two letters are the same color, last two are the same color, first and last are the same color. So a couple ways that we can try to set up these ratios to solve for missing values is color coding is helpful. But if you look for side A in the diagram, side A is this guy right here, DT. So that's the unknown I'm looking for. That I've color coded with red, and you can see it matches up with the number 7. Then I need another ratio where I know both values. So you can see B is this one here that I don't know, so I can't use the purple values or I'll have two unknowns. So I'm going to use the two yellow values. Now A was in the small triangle, so I'm going to match that up here, small triangle over big triangle. And to solve this, we would cross multiply. So 8A equals 6.4 times 7. 8A equals, actually I'm just going to do it in one step. So then we would divide by 8, and I get A equal to 5.6, like that. Okay. That's one way you can go about it. You can just look at the sides, which ones match up, and try to set up your ratio. If you need a more systematic approach because you have a hard time matching things up and seeing how they pair up, then what you can do is you can write the ratio of the corresponding sides like we did it in the past. So PB is your first two letters over your first two letters equals the last two letters, which is BK, over, and when I say last two, I'm talking about in our similarity statement here, TD, and then first and last of our first triangle, so I've got PK, and first and last is ND. So if you've got your similarity statement, then you can go ahead and substitute your values in. So if I look along PB, that purple line, PB is 6, NT is B, BK is 7, TD is A, PK is 8, and D is 6.4. And once you get those ratios set up, you need to find which one you know both pieces of. And in this case, I know 8 and 6.4. You need to pair that ratio up with one of the ones you're trying to solve. So I've already done the A value, and you'll notice that I have 6.4 over 8 here, and here I have 8 over 6.4. Doesn't matter because the other one's also flipped upside down, so we can always flip them if we want. But this guy over here, I'm going to grab 6 over B, because that's the one I'm trying to solve for, equals 8 over 6.4. So although we do have 3 sets of ratios, you only use 2 when you're cross multiplying. So you need one that has your unknown variable, and the other one has no variables in it. Cross multiply this out, so we get our 6 times 6.4 equals 8 times B, so 8B. Alright, sorry, I just flipped up here. Okay, so divide both sides by the coefficient of 8, and we get B equals 4.8. Now, since this question started with decimals, our answers as decimals are acceptable. So coming down, I just moved my screen. Coming down to the next example, as soon as I move my screen back, there we go. Example 2, prove these two triangles are similar and state the similarity statement. So it might be hard to see, but there are these little teeny weeny arrows on here. So using my Z pattern, I can tell you that angle B and angle C are equal, angle A and angle D are equal, and that middle point, angle E and angle E, are equal. You need at least 2 of those stated to tell me angle similarity. So this guy's because of your Z pattern, this guy's because of your Z pattern, and these guys are opposite angles, or opposite angle theorem. And state the similarity statement. So we've got to put our therefore triangle B, A, E, just following the order I've written here, is similar to triangle C, D, E. So solve for sides A and B. So if you feel comfortable figuring out which one A matches up with, which one B matches up with for the second part, and finding that ratio that matches up where both the values are in there, you can just go ahead and try to write your proportion and solve it. If you're not sure, what you want to do is make that ratio of the corresponding sides. So first 2 letters, BA, is going to match up with, in the other triangle, CD, this guy over here, CD. Okay, so first two done, last 2, AE over DE, and then first and last, BE matches up with CE. Then we go to substitute. So I just find BA on my diagram. So from angle B to angle A, got a little B along the side length. CD is 1.5. AE is 5. DE 2. BE A, and CE is 3. So in order to set up my proportion to solve first for A, I need the ratio that has the A in it and the ratio that has no variable in it. If I didn't have a B and I had a number here, you would be able to choose either of them. It wouldn't matter. So we've got A over 3 equals 5 over 2, and cross multiply. So A times 2 is 2A, and 5 times 3 is 15. Now here I didn't start with decimals. You're not asked, to give an answer to a word problem where decimals may be appropriate, so we can just leave that as fraction in those terms. We get 15 halves. Over here, I want to grab now my ratio that has the B in it and the ratio that has no variable in it. I could use A over 3 and just substitute in this A value, but as you can see, it's not a really nice A value, so let's not do that. Also, if you make a mistake on your A value, now they're both technically wrong. So this one here, cross multiply, you get 2B. I have a decimal, so I'm getting a decimal, so we'll just keep going with that. Divide both sides by your coefficient, and that gives me a decimal of 3.75 each. Kind of got squished in there for that final answer there. So one more example, and then you guys are going to try some on your own. So on the next page, prove these two triangles are similar, and then state the similarity statement. Angle A equals angle A, nested triangles. We have that shared angle at the top. Angle B equals angle D, so that's these guys. And that's because of our F pattern. and angle C is in the smaller triangle, pairs up with angle E in my bigger triangle. Again, F pattern. So this is angle-angle similarity. And we can state that triangle ABC is similar to triangle ADE. And because of the way I set them up here, it makes my similarity statement writing real quick. This one's one of those ones that's a lot easier to see which ones pair up because they're not spun around or rotated or flipped anything crazy. It just literally, this bottom line got stretched downwards. So for this one here, if I wanted to solve for A, that's this missing side here. So A and 10 match up. 3 and trick, the whole side, which is 5, match up. And over here we've got our 4.5, the small side on there, and the whole thing, which is x plus 4.5. X only goes from C to E right there. If you want though, you can write those ratios of the corresponding sides again and substitute just like we were doing on the last page. So AB matches up with AD, BC and DE, AC first and last, AE first and last, and then just go ahead and substitute and cross multiply. So you can do that if you'd like. I'm just going to go through it a bit quicker. So I want to solve for A. So I know I'm going to have to use A matched up with 10 for sure. And then I need another set where I know both values. So over here I'm sitting with X's. I don't want to touch those guys. I'm going to grab those green numbers. So A was on the small triangle, so I'd have to put the small triangle value on the top. The big triangle is the whole thing combined. This is one of those questions where I could totally cross multiply it, but I don't really have to. The relationship between these two numbers is just that from the green one to the purple one, it's double. So to go from the green one to the purple one up here, I can just double it. You show a little quick indication like that, showing your work, and I'll know how you got your answer. A equals 6. For the next one, X, this one is where it gets fun. So again, we can grab our two ratios. So our green ratio I have already. That one's 3 over 5, small triangle over big triangle. So I have to do the same thing over here. Small triangle is 4.5 over big triangle, which is x plus 4.5. Cross multiply these guys. So 5 times 4.5 gives me 22.5. When I cross multiply these, this has to be into brackets because the 3 has to multiply by the full denominator of that ratio. We've got our 22.5. Multiply that 3 in using our distributive law. That gives me 13.5. And start solving our equation. Subtract the 13.5 on the other side. That leaves me with 9. Divide out the coefficient. And I get 3. Now the one thing that we haven't seen with these questions is units. These questions have just given us that numbers without any units, but when you do have problems where there are units, make sure your final answers include that. So another long video, but this is the last one for the unit. There are 3 for you to try on the next 2 pages. So make sure you work, 4 actually. Make sure you work through those right now. Come back, check your solutions. See you in a minute.